Hello, this is Point on Pally again, and welcome to part 2 of the animation path video series. And in this video, we will be discussing how to connect the animation loop rig into the RFL setup on a biped character. Now, first thing I want to point out, you might notice something a little bit different compared to the previous video, or the rest of my videos for that matter, is I'm on a PC now. The Mac I had has died, so I am now working on a PC instead. So if I'm mistyping things or if I'm pressing the wrong button sometimes, I'm just getting used to a different layout of the keyboard, so bear with me there. Now, I've got this kind of walking nose character that I've really liked, but it's perfect because there's not much to him outside of the legs, so this is the perfect character to do this setup on. And I'm going to point out a few things before we get started on actually building it. There's a few notes I want to explain about this setup. So the first thing I want to do is explain actually how this setup is going to work. So we have, if I turn this on right now, nothing should be moving because the offset's at 0, but if I hit play, you see we have the animation setup, the basic setup that we did in the previous video. We have that working right here. And now how this setup is going to work is we're going to use, since the main driver of this motion is this motion path. So if I go into the actual setup here, show this. So here is the animation loop setup that we had made, or it's the same one from the previous video. I've just hooked up this character up to that same setup. And the key driver of this whole thing is this locator. It'll actually let me click it. There it is. This locator following the top half of this nerve circle via a motion path here. And the key aspect here is this U value. It is a 0 to 1 value that allows the locator to move along the entirety of the path. And we've set up an expression to have it loop around. So this U value here is what is going to drive the rotation of these RFL joints. We're going to use certain points of the animation, specifically the origin, the back point here, which is going to be for the toe, the top of the arc here, the frontmost point, which will be the heel, and probably midway around here is going to be this flat position, and then the position for the ball joint to lift up is going to be somewhere right around here. So we're going to stick to certain points of this animation, and these points are going to drive the rotation of these joints. So that's kind of the basic setup that we're going for here. And I was talking of these milestone points here. The reason, and another note I want to make here, is for this setup to work, or at least the setup that I'm using for this, the way this is going to work is we're going to stick to certain milestone points for specifically the offset. And what I mean by that is this setup works for a biped character. If I turn this one on, you'll notice that the path offset here is set to 10. So right now, with the left offset at 0 and the right offset at 10, these are 10 points apart, which means they will be reflecting movements. They will be the kind of opposite. So when one foot is at the origin point here, the other one's at the top of the arc. When one foot, if I go forward a little bit in the animation, when one foot reaches the frontmost point here, the other foot will be at the backmost point. And this setup only really works for biped character if the offset for each foot is 10 points apart from the other. And so what we're going to do with this setup is we're going to set it up so that it's going to work at these kind of milestone points, specifically 0, 10, or -10, because that's kind of, if I set it to -10, it's the exact same point, really. See, it doesn't move. And we're going to also use -5 and 5. So if I were to set this to -5, we get the reflecting movement again. So the point is, we're going to stick to those milestone points and those milestone points only. And the reason why we're going to do that is the main reason for excuse me, is because the U value with this expression, when it hits 1, it reverts back to 0. So the problem is setting this up so where certain points, when it hits that 1 value, it'll actually trigger the animation in the proper way. Because when it flips back to 0, it can cause some issues with the rotation values of the joints. We'll get into all of that. But the reason we're sticking to these milestone points is we're going to, with that extra setup to convert the 1-0 flip or the looping of the animation, this is very difficult to do at any certain point. So that's why we're sticking to the 0s, the -5s, the 5s, and the 10s and all that. It's a lot easier to set it up if you're just sticking to those certain milestone points. So with that, let's get started. And one more note I want to make is this is going to require a little bit of work to get this to fully work with these setting these milestone points, but very similar to the basic animation loops video we did previously, this is all very easily scriptable. So if you like this setup and you want to use it not just for one character but for multiple rigs, feel free to script this out as you do it, and then all you have to do is basically click a button and it'll work for you. But we're going to show you how to do the entire setup, at least for the left foot, and then we'll kind of just fast forward to the right foot being done. All right, so let's get started. Okay, so the first thing I'm going to do is I'm going to create a series of attributes, of 0 to 1 attributes. And these attributes are going to mark these milestone or these certain points of the animation loop, specifically the origin, the ball joint position, the toe, the top point of the arc, the heel point in the front, and then the flat point somewhere around here. So there's going to be 6 different points. So I'm going to create one attribute for each of those points. And those attributes are going to connect directly into the node setup that we do. The reason why I'm doing attributes is so that at any point, if you're happy with where everything's set up, except for like a couple of areas, like you want the foot to come down flat at a certain point a little bit sooner, you can break the connections that we're going to have on the attributes and you can manually adjust them. So that's why I wanted to do attributes, to make it a little bit more adjustable. So not everything I'm doing is set in stone. All right, so let's create the attributes. So what we're going to do, oops, I want this here. I'm going to hide this whole setup in here. There we go. So I'm going to create some attributes, and I'm just going to use my handy dandy tool here and just make some quick attributes. First, I'm going to create a separator attribute. It looks just like this. So I'm just going to call this animation loop RFL. I like to have my separator attributes be all caps so that it kind of differentiates itself from, I know that one's not really in all caps, but normally I like to do that. So there's a separator attribute. Next, we're going to create some float attributes, and these are going to be a minimum of 0 and a maximum of 1. This is very similar to the setup I'm doing for the actual add attribute setup here. It's going to be basically the same, min 0, max 1. It's the same thing. I just have a small tool for it here. So we're going to call this, let's see, I'll call this, oh, getting used to the keyboard. There we go. Path heel, add an attribute on it. Next we'll do path toe, path ball, path flat, path top, and path origin. There we go. All right, so there's our 6 attributes. Now what I'm going to do is I'm actually going to use this path offset attribute here, and I'm going to key the values that I need these attributes to be at these certain milestone points in the path offset. So I have a little cheat sheet here. If I open the script editor here, this is a little cheat sheet. There's some information here that we're going to use to set up the nodes and all that, but this is kind of the cheat sheet for the attributes. Basically, this is what I've tested out to see what works here for these numbers, and this is kind of like the best I've come up with at this point. So we're going to set these attributes up. So at offset 0, the heel is going to be 0.75 because if I go to, let's say I go to the frontmost point of the curve, if I were to go forward to right about there, and we go check the motion path, you'll see it's right about at 0.75. So we know that that is the point of the animation loop where the heel is when the path offset is at 0. So let's deal with the rest of the numbers. So the toe is 0.25, so that's the opposite point of the path. The ball is 0.1, so it's a little bit before the toe. The flat is 0.9, so that's right after, shortly after the foot hits the heel on the ground. So shortly after it's flat. The top point is at 0.5. It's the opposite point of the origin, and the origin is at 0, since the offset is at 0. Okay, so with that, we're going to set up the set-driven key. And I just want the icon itself in the driver and the driven. So path offset is the driving attribute here, and the rest of these are the driven attributes. So with everything set up here, I'm just going to hit key. So next we're going to go, let's start with 5. So I'm going to set path offset to 5 and adjust these attributes as needed. So for 5, let's pull up our cheat sheet here. So at offset 5, the heel is at 0.5. The toe is, I have it marked 0 to 1, so that's just going to be the point of the animation where it kind of loops back around. So I'm going to mark it as 1. The ball is at 0.85. The flat is at 0.65. The top is 0.25, and the origin is 0.75. So hit all that and key it. Next, we're going to go to 10. Let's check out the attributes here. So 0.25 for the heel, 0.75 for the toe, 0.6 for the ball, 0.4 for the flat. The top is 1, and the origin is 0.5. All right. So with that, we'll just key all that. All right, so let's go to -5. And let's adjust all these. So -5, the heel is at 1, the toe is 0.5, the ball is 0.35, flat is 0.15, the top is 0.75, and the origin is 0.25. Key it again, and lastly, -10. So at -10, this is the same as it was for +10, so 0.25, 0.75, 0.6, 0.4, 1, and 0.5. All right. So that should be good. Alrighty, so I think we have all the settings. So let's just check. So if I hit 5, these numbers all line up. 10, numbers all change, -5, and 0. Okay, so the attributes are set up exactly how I want them to be. So at this point, we can go into the node setup here. So for the node setup, the first thing I'm going to need are the heel, the toe, and the ball joints. So I'm just going to load these in here. And the important thing I need in here, so all this right over here are all the set-driven keys that I have for the basic RFL setup. So I just have a bunch of attributes here to control rotations on the joints. They are hooked into these multiply divide nodes here, which I have a multiplier set on them, and then that is funneled into the rotations of the joints. So it's just primarily set-driven keys with a multiplier attached to them. But the good news is that we can use the existing setup we have, and we can actually add to it. So, regardless of the RFL setup you have, you should be able to add the existing setup that we're going to, or the new setup that we're going to do into this existing setup. So the important thing I need here are these RFLs. So all I really need here is this. So, but I want the icon, so I'm just going to hide everything else in here. And we're going to stick with the heel for now. And I want to stick with just the rotate Z, because the rotate Y is for the twist, and we don't need the twist for this. The twist is kind of its own separate thing. Alright, so all we need is this, and the output X going into this. So all we're going to need, we're going to start with the heel, and all we really need for right now is the output X of this multiply divide. So everything else we're going to just shift up here. So I'm going to get it away from what we're doing. Alright, so for this setup, we're going to need multiple attributes, and we're going to start with the basic 3. We're going to need more eventually, but we're going to start with the basic 3. We're going to need probably my favorite node at this point, the set range node. It's kind of its own, the node version of a set-driven key. It allows you to convert certain an existing range into a new custom range. So we need a set range node, we need a multiply divide node, and a plus minus average node. So the set range node is what's going to convert the U value of the motion path into the rotation values. The multiply divide is going to connect, it's going to turn everything on and off. We're actually going to connect the animation path on off attribute. We're going to actually convert that. We're going to use that to funnel into here to turn it on and off. And then the plus minus average is how we're going to combine this multiply divide node plus the multiply divide node of the old setup, and we're going to add them together and then funnel this into the RFL joint. So this node here is how we're going to add everything from the new setup into the old one. So before I get started, I'm going to name everything before I forget. So we're going to call this left anim path heel set range. Oops, forgot the underscore there. So there we go. Zoom in a little bit. Copy this and paste it in here. Heel, I'm going to call this heel on off, multiply, divide. And we're going to take all this, plug this into the plus minus average. There we go. I'll call this heel at. All right, so we've got our nodes here. All right, so let's get started. Oh, and the other thing I'm going to need is the motion path. So the easiest way I'm going to do that is up here. Since I only have the 2 motion paths for each foot here, if I do star motion path star, it should select just the motion paths here, so I can just add these to the existing scene. There they are, and I'm just going to hide the right foot. So here's the motion path because we need the all-important U value here. So we're going to take the U value and we're going to drag that in to value X and value Y. Since this is the U value is the driver of the whole thing, we're going to plug that in to the animation path. Now the old min and the old max are going to be these new attributes that we created. So since this is the heel, the point in the animation before the heel, so if you think of the walk cycling animation, the foot comes back to the toe, then it comes up to the top point here before it comes down to the heel. So the top point is the point in the animation right before the heel. So we're going to plug into the old min path top here, since that's our old minimum. That's the old min x here, and the old max x is going to be the heel, because that's the first part of the animation, is getting to the heel. The second part of the animation is going to be turning off the heel. So for old max x, we plug in the heel there. The old min y is going to be the heel, because the next part for the y value is going to be turning off the heel. So, oops, it should be old min. So the old min y is the heel, and the off point should be when the foot goes flat. So that's the flat point. That's why we created this attribute. So it's to turn the heel off essentially. So old max y is the flat. So there we go. So it goes from 0.5 to 0.75 for the heel, and then from 0.75 to 0.9 to turn it off. So what are our values going to be? So it can be whatever rotation value works for you. Typically a solid number is kind of like an extreme number for an RFL. I like to go with 60 degrees. So when we go from the top point of the arc to the heel, we're going from 0, so it should be flat, all the way to the 60 degrees. So min x is 0, max x is 60. And what I'm going to do for the y value here for min and max is I'm going to set it from 0 to -60. Because I can't set it from the min to the min y being 60 down to 0, because then it's going to add the 60 from the max x and the 60 from the min y together. So you actually have 120. So by doing this, it's essentially going to cancel out the 60-degree rotation here with the -60. So it's essentially going to add the -60 here, and we'll eventually turn it off once the U value gets to 0.9. Alright, so that's pretty much it for the set range node for now at least. So I'm going to plug this into the multiply divide node. So we're going to plug this in to input 1x and input 1y. And I'm just going to take the animation path on off attribute here, and I'm just going to plug that into the input 2x. So that the Boolean attribute here is just a 0 to 1 attribute. So it's going to multiply by 0 if it's off, which means it'll turn it off. And now we're going to add this with the existing setup here. So remember how I said the output x here? This is the rotate z of the RFL joint, for the heel at least. So I'm going to plug that in to input 1d 0. Excuse me. And I'm going to plug output x and output y into the multiply divide node here. And then from there we can plug the output 1d into the rotate z to replace the existing one. We can actually get rid of that unit conversion node now. There we go. So now this is added into the old setup for the RFL. So now we've got it. So with everything connected, let's test it out to make sure it actually works. So now you can see we're getting that range of motion. If I go frame by frame, start back. So we're at the top of the arc here. So the heel starts to activate as the foot comes down and the foot hits the floor. And then shortly after, as if the body's weight were going to come onto the foot goes flat. So there's our animation. Sorry, I'm sneezing a lot. Now, this should also work, if I check, I think it's either 5 or -5. Let me check, I think it's 5. So if I check 5 and I run this, so 5 starts at the back here. So if I check this, it should also work for 5. Now, it's not going to work for -5 and it's not going to work for 10. And we'll go into fixing that right now. But you see what happens when I hit -5. -5 means the animation is going to start at the heel. So this is where that 0 to 1 animation loop for that U value comes in. And so obviously you can see what's happening here, where it's not working correctly. And same thing for the path offset here, when I set it to 10, because that means the animation is starting at the top point, so the loop is happening here. So it's causing some issues when it reaches the loop part of the animation. So we're going to create fixes for both of these points, for the top point when the offset is at 10 or -10, and for -5 when the animation starts at the heel. So we're actually going to start with the offset at -5, and we're going to make the correction for that right now. So the way we're going to correct it, the real problem here, you can see with the set range here, where the old min x is at 0.75 and then it goes to max x 1, which is good. That's how it's supposed to be. But the problem is, you see the old min y starts at 1, but the old max y is at 0.15 because this is the flat point of the animation. So this is when the foot goes flat at 0.15 of the U value. So what we need that min y value to actually be 0 instead. So what we're going to do is we're going to use just a regular old condition node. And I'm going to copy that, bring this in. Okay, so all we're going to do here is we're going to plug the path heal into the first term here. If I open the attribute editor, we're going to say if the path heal attribute is equal to 1, meaning it's essentially the offset is at -5 and the heal is the starting point of the animation. If it is equal to 1, set the color of true to 0. And if it's false, just use the heal attribute. So we're going to plug this into color if false. So meaning if this attribute is equal to 1, the number is actually going to be 0. If it's not equal to 1, just use the path heal attribute normally. So the other thing I want to do for this condition is I'm going to set up 2 other conditions here. And what these are going to do is they're going to adjust the min y and the max y here. Because the issue we run into right now, as I've shown you, is you see how the foot is constantly active at -60. So the reason is when it goes from 0.75 to 1, it activates at 60. But the second the animation loops back around and it starts at 0 again, that 60 turns off. And so the -60 is just going to be active at all times because it's starting from 0. It's starting at 0. So the 60 is off, but the -60 is turning on. This is the problem that we're running into. So the way we're going to fix this is we're going to flip the min y and the max y to different numbers. And the numbers we're going to flip to are going to be right here. So for color if true here, we're going to plug 60 in, and the color if true B is going to be 0. But otherwise, we want to keep the original values, which is 0 to -60. So let's plug those into the condition. So 0 here and -60 here. So with that, we're going to plug the output G into the min Y here. So now that is set to 60. I'm going to plug out color B into max Y. So now that's set to 0. So what we've essentially done is say, okay, so when it's 0, start at 60 and then go back down to 0. And so now if we take a look here, you can see the foot actually looks correct. So before I test this, I just want to make a note here is I cut away for a minute because even though the connections, everything here is correct, everything seems to be working correctly, it's working exactly how I want it to. For some reason with motion paths, it doesn't auto-update correctly sometimes. For some reason, the joint was having a 60-degree rotation all the time throughout the animation, despite there being no 60-degree value here or in the plus minus average. When it shouldn't have that 60-degree value, it still had it there. I've had this run-in with motion paths a little bit where they auto-updating in real time with direct connections sometimes is a little buggy. I found that the solution, and I just did this, is to actually save your scene and reopen it, because sometimes that will actually fix the this auto updating problem with the motion path. It'll actually kind of get the motion path to, like, it saves the settings and kind of fixes it, it corrects it. So now if I run it, it's the exact same settings as I had, and now you see that it works. Before, for some reason, it was just staying active at 60 at all times, despite not having the correct values. Or despite everything working correctly, it should be at 0 for the rest of the animation, except right around here. but for some reason it was staying 60 at all times. Again, this is a motion path bug, but the solution to that is to save your progress and reopen the scene, and the fixes should be there. So now we've got it working at -5. This should also be working at 5. So if I hit play here, it's working at 5. It should be working at 0. And as we just fixed, it's also working at -5. So now we've got it working at those 3 milestone points. So the last milestone point we need to do is the 10 and -10 milestone point. Specifically, we need to fix it so when the foot is at the top of the arc, the heel is not active. So what we're going to do is we're actually going to do a similar setup to what we just did. We're going to create a condition node for the top point in the animation and plug that in place of the top point here. Because you can see right now the old min x is set to 1. We just need to flip that to 0. So it goes from 0 to 0.25. So we are actually, I'm just going to duplicate this setup. And I'm going to call this the top condition. And we're going to do the same thing that we did for the heel. We're going to plug the top into the first term. So saying if it's equal to 1, have the color of true R be 0, and the false will be the path top here. All right. I don't think we need to add any rotation values in. Yeah, I don't think we don't need to do that for this because it's dealing with the start of the point, not the actual heel point of the animation itself. We're just dealing with the top, so I don't think we need to do that here. We don't need to mess with any of the other values of the condition, so we can actually just zero everything out in here except for what we need. And we're going to plug the out color R into the old max X. Oh, I mean, sorry, old min X. There we go. That's the one thing that always bothers me about the set range node. How in the channel box, old min and max, old min is on top and old max is below it, but in the node here, it's old max is on top and old min on the bottom. So that always kind of throws me through a loop for a minute. Okay, so now the value is at 0, so we should see, and we're still getting that flipping value. So let's see. So when it's 0, 0.25. So this might be a similar issue that we were running into before. So what I'm going to do is I'm going to save the file and reopen it and see if that fixes the problem. All right, so we're back. So just as I suspected, if I saved the scene and reopened it, and that problem went away. So now, as you can see, everything is working just fine. So now we've got the heel set up for every single point of the animation. So if I set this to -10, it should move exactly the same. If I set it to, let's say, 5, it's working. If I set it to -5, reset it, it's working. And if I set it to 0, it's working. So we've set up the heel for all 5 of those animation points. So I can mark the heel done. And at this point, we can move on to the other parts of the RFL, the heel or the toe and the ball. So since this video is run rather long, I'm going to put the ball and toe joints into the part 3 of this video series, and we will move on from here.